So this is the lesson number 19. Let me write down. Let's do lesson number 19. And this is about 19 is students' task. I always call this students' task, where students have to do this. Okay, what do you see and what do you notice? Now, there is a graph. I notice a graph here, and which is a parabolic graph. I just write here, this is a parabolic graph. And why do you say this is parabolic graph? Is they also give us an equation which has which is a polynomial here. So this is a equation with polynomial with a degree. So I want to write one more time just to show x square there plus 4x plus 0. So this is called, actually, if you compare with your equation, the regular equation like ax square ba, this is an equation in the standard form. Okay, this is called standard form. And if you compare with the standard form, and you don't see a number here in the equation, that's why I put C here. And that C is the y-intercept. If you remember, this piece is y-intercept. And you can see the graph that you see here. The y-intercept is the graph goes through the 0, 0. That's the y-intercept, 0, 0. So this output, which is the y and x here. So y is the output. So the understanding of standard form, the number by itself is where the graph crosses the y-axis. And the second part is they also give us, and this is positive. So another observation, this is positive. So you can see this graph is concave up. So another word you have to know is what is concave up means, or the parabola opens up. And it's because it's positive. So because the leading coefficient here, because this is the leading term of a quadratic function in the standard form, the leading term is positive, and that's why it is. And then you notice also is here f of x. This is the important information I'm putting in green color. And what does that basically means? F of x is 0 means actually you're saying the y is 0. When? So what this means is when x is 0 and -2, the y is 0. What it means, you have 2 points here where y is 0 so the output y is 0 for the input 0 as well as -2. And if you see on the graph, you see those things I'll mark with the color to show this point and this point. So those are the graphs where those are the point where the graph crosses the x-axis and the y-axis. Sorry, the x-axis. So these are called the zeros of the. They are also called the zeros of f of x, the function. Whatever the function, those are called zeros. And we also call them x-intercept because that's where they cross the x-axis. So this is what you see and what you notice here. So question about what you wonder in this case, maybe you may be wondering why is this given, maybe, or what is the minimum. And you see there's a lot of information here to know that the lowest it goes to is the vertex. If those, so vertex is the point where it takes a turn, that is, and you can see it takes a turn at -1 and -2. So this is the vertex. Besides that, it is also has minimum. This it's like h and k. If you remember, it is h and k, where the minimum is the k. Okay, and there is also axis of symmetry. What is axis of symmetry? Is this one? So there's a line like this. This is a line of axis of symmetry, where the equation is is x equals h, but the h here in this example is it is -1 here. So that's -1 is the axis of symmetry. If you want to know the range, there's also range. The lowest it goes is, so you say, okay, k to plus infinity. In this example, the k is, in this example is, the lowest it goes is -2, and then all the way goes up here. So a lot of information I'm giving just for the, because of the ACT, it helps you to understand what is the meaning of range also. This piece is called interval notation. This is called interval notation, but we can also write in the set builder notation is like this: less than equal to x, equal to y, and then less than plus infinity. Okay. Next is you have a second example. What you see here is what's the difference between the one that you saw earlier. You have seen the graph had crossed two places. So there were two solutions. Remember, it went through 0 and it went to -2. So the graph was something like this, okay? And it was like this. So that graph had two solutions, which I forgot to write there. This one, there were two real solutions. The one that we did earlier is two real solution. Why there are two real solutions? Because the graph crossed the x-axis two times. Now, what you see in this one, the one that is given, they also gave you the actual number constant, which is on the number 2, and that's the y-intercept. It crosses the y-axis at, this is that point 0, 2. It crosses this. But the main thing is the solution basically in this example is the graph. This graph, see this green graph. So this graph, sorry, the blue graph, it takes a turn. It bounces at -1. And basically what this means is bounces means there is a two factors. X plus 1 becomes a factor. See, so one of the x-intercept, which is x is -1. Yeah, let me write it nicely here. X is -1 is the solution. So this is the solution of the quadratic equation 2x squared plus 4x. If you put it equal to 0, it means you want to know when is this going to be 0, when is the output is going to be 0. So that's what that means. So this gx that you see, it means you want to know when is the output is going to be 0. But they already gave us the answer. See, this is x equals -1 is where it, but my question is, what about how many real zeros are there? It's the same real zero. So when you add +1 both sides, so it means you end up getting x plus 1 is 0. See? So basically there is a degree 2. And if you really apply your mind here, see, this is nice. So x plus 1, uh, I can undo distributive property where we can always take 2 out, pull out the factor 2 out. So what stays is x squared plus 4x and plus 2 plus plus 1. Okay, I made a mistake. This should be 2. My okay, so 2. So that is a perfect trinomial. If you see this, half of 2. If this number 2, if you take half of 2 is 1, and if you square it is 1, which is right here. So that means that expression is a perfect. This is perfect trinomial. So if it is perfect trinomial, we can write it as 2 into x plus 1 the whole square. So what this means is that x plus 1 is repeated twice. So this is 2 is outside, x plus 1, and another x plus 1. So there are, so even though this answer that you see is, it is a one real solution. So what I suppose, this is one real solution, and it is repeated twice, so repeated 2 times. And when you say repeated 2 times, means 2 times, this x equals minus 1 has multiplicity. If you remember the word, what is the multiplicity of that 0? This is the 0 also. Uh, so we write right here multiplicity. So this is with multiplicity 2. So 0 with multiplicity 2. So because it's the same 0, it's the same. So you don't have a separate in like how you had the one before. Here there were two solution. X equals minus 2 was one of the 0, and x, so there were two real solutions. It is, but here it's just one solution which is repeated. That's all it is for this problem. Let's move to the next one. So this is the third example which clearly shows that there is a parabolic shape which is up because of the quadratic. The degree is 2, this is degree is 2. But how many solutions are there here? How many real solutions are there? Clearly the graph that you see, this graph does not even cross x-axis. So it takes a turn right here. Okay. So because it does not cross that, okay, it does not cross, we say, so I will say, hey, the graph does not, so this graph does not cross x-axis. And because it does not cross so, so this function hx, the function hx, uh, uh, equal to 0, or you say this equation equal to 0, or this function does not have real zeros, does not have real zeros. So because it does not have real zeros, so we say, okay, it means we can write it has complex. It has some solution, maybe x equals, and that's what they gave us. See, those are the answer they gave called complex solution. So x equals minus 1 plus I, and the other one is minus 1 minus I. These are called complex solution because they are not real. There's an I there. So if you forgot what is I is square root of minus 1. That's all it is. And if you square, I square is minus 1. Okay. So this is that imaginary unit. And because it does not cross the x-axis, we say, okay. And one thing you can at least notice is maybe this is the y-intercept. See, 0, 4, the number by itself, which is a constant here, that is the graph where the graph crosses the y-axis. Okay. And you can see this graph has a minimum of, I can write the vertex here, minus 1 and 2 here. So the minimum or relative minimum, this is the relative minimum here. So a lot of information I'm writing there. Minimum is 2. If you write h and k, your k is 2. Okay, and the range is 2 to, it goes all the way to infinity. So this is how you write in the interval notation. And the question is our next lesson will not next activity, where the heck we got this from, right? We want to know how this, how did we end up getting these answers, and that's the next page, I think. Okay, suppose I want to find let's solve this, okay? And you can see this equation, even though if you write it, if I pull out 2 and write it as x squared plus 2x, and we cannot factorize this even, x plus something. We don't have answers that multiply to 2, two numbers that multiply to 2, and they add up to 2 also. That's not possible. So what we do here is called, we are using quadratic formulas, which is x equals minus b plus or minus square root of b square minus 4ac divided by 2a. So then what is that? A is 2, b is 4, and c is 4. So if you plug in these three values in the formula, you can see it's like this. So it's minus b, which is 4, plus or minus square root of b square, that is 4 square minus 4 times a is 2, and c is 4, and then divide by 2 times 2. So just plugging in those values, and you simplify this further down. You can do mental maths and see here. 4 times 4 is 16. So this piece will give you 16. Okay, that's 16. And 4 times 2 is 8, and 8 times 4 is 32. So it's like 16 minus 32. You end up getting negative 16. And that's like a negative number inside the square root sign. And divide by 4. But what is square root of minus b? We know this directly, square root of b times I. So in this case, square root of negative 16, we can write it as square root of 16 times I. And we do know square root of 16 is 4, so 4 times I. So this whole thing reduces to negative 4 plus 4I. See, divide by 4. And the denominator 4 divides both. This 4 divides this 4 divides that 4, so you get minus 1 plus minus I. So there are two answers for this. One of the answer is x equals minus 1 plus I, and the other one is x equals minus 1 minus I. And that's how, sorry. So that's how you get these two answers there. So you may be thinking, wondering, what is this? How did you get kind of thing? But we are using the quadratic. So this is the quadratic formula which we learned earlier. And because we could not factorize this, we could not do this piece. So we are using quadratic formula to get the answer. I hope that helps. Okay, let me put the first one. We need to know. So this one I will write 1x squared minus 6x plus 5 equals 0. The first step is I will say what is a, b, c, and you can see a is 1, the number before x squared. B is a number before x, that's minus 6. Okay. And c is 5. So the number by itself, that's 5. Okay. So this is the first step. And once you know this step, you write the discriminant. What is that discriminant? D is. So I know you can just put an arrow and do the work. So you could break this into 4 places up here, one problem here, one problem here, one problem here, and down. Okay, so you can have your own ideas. So what I'm going to do is I'll write D is the discriminant is B square minus 4AC. That's the formula. So all you do is plug it in. What is B? This goes right here, which is negative 6, the whole square, minus 4 times the A is 1, there it is, A is 1, and C, the constant number is 5. Okay, negative 6 times negative 6 is positive 36, okay, and minus 20. You can see 36 times, you take away 20 from 36, you get positive 16, and you got positive answer. So what that means is this number is greater than 0. And that's why positive means you have two real solutions. That's it, you're done. So you're supposed to do this for each of this case. Uh, so in this case, prediction, what should I write? The prediction is uh, because the D is greater than 0, of course, the work is right here. We have two real solutions. And you're done. So that's how you do. Let's do the Uh, I'll leave this for you guys to do. Do the same way. Let me do the other one so that we understand what I'm talking about when there is a negative. Okay. So the third one, let's do. So the third one is minus 1x squared because there's no number. So the number is minus 1 and then plus 6x minus 9. So step number one, what is A, B, C? Let's write that. A is, so this is the A, this is the B, okay, and this is the C. See, once you get this A, B, C, all you do is write down D is B square, formula is B square minus 4A and C. What that means, you square the B, so the B is the 6 square, and then times A is minus 1, and times minus 9. Okay? So when you do this, you get 36. And you can see this two negatives will make it positive. So this two negative will be positive, and you will still there will be one negative sign stays. And then when you multiply all this, 4 times 1 is 4, and 4 times 9 is 36. And 36 minus 36 is 0. So here, this one you got D equals 0. So we say one real solution. So this is how you figure out. So, so what this means is if you get a negative, see the last one, if you see this, in this case, you may say, what is this? Minus x squared plus 0 plus 0x minus 9. It means your a is minus 1 here. This is the third one. The last one, a is minus 1. B is 0. And C is minus 9. And when you work out like this, and you can say the B is 0. So 0 square minus 4. A is minus 1. And C is minus 9. So if you work this out, you get 0. And there are three negatives, so one of the negatives still stays, and 4 times 9 is 36. So you get you get negative 36, and this negative 36 is less than 0 or negative. So because it is negative, we say 2. So the answer here is 2 complex. Okay, so this is 2 complex solution. Okay, I left the second one for you guys to do. It's almost the same thing. So, okay, so you're supposed to create your own equation. Uh, Come on, just put some numbers. Only thing you want to make sure there is a x square. So you're supposed to create some number like this and some number like this, and put equal to 0 like this. So you're trying to create an equation here. Okay, very good. And I'll take minus. Just like that, because those are already positive, so you can take one negative equals 0, right? So all you do is you create your equation and try to do the same thing. What I'm talking about is here in this example, A is 5, right? B is, what is B here? 2, and C is negative 3. The whole number, it's like full thing, okay? Once you get these three pieces, what is D means? B square minus, okay, and then you try to put square the b, which is the 2, minus 4 times a is 5 times the minus 3. Agree? And then this becomes 4. Two negatives makes it positive. 4 times 5 is 20, and 20 times 3 is 60. Oh, you got a six. Oh, God. So you got 60 here, but 60 plus is a beautiful number, perfect square. This is called perfect square. Perfect square means the square root of 64 is going to be 8. That's why I was laughing. So it's like this one has two real solution because the number is positive, two real solution. But besides, you kind of get a rational zeros. What I'm talking about is your formula is like this, and this is plus or minus square root of 64 here like this. So basically, what's going on is you are ending up this whole thing. The radical sign vanishes. So that when the radical sign vanishes, what this means is you get rational zeros. So it's not just real zeros, but you also get rational numbers because there's no radical sign. It vanishes. So that's kind of a beautiful answer we got at 64 in this example. Anybody else wants to give another equation? We still have time, like how uh, Jade gave. Can somebody else give another equation quickly? So the one that we got is two real. So why did you say two real? Because this was positive. That's it. You're not supposed to do anything more than that. But I was very happy because that was a perfect square number. Because when you put in this side, uh, you you um, the radical sign vanishes. Now I want Excel to give me one equation. Excel. Ah, she already gave 5%. Change this. We can put negative also. Okay, negative 3x squared then plus 4x plus 1. Okay, see, that's another one. And you do the same thing. So let me wipe this off, all this piece, and put this over here. Can you all do that by yourself? So this is what Excel put us. So let's see what Excel gave us. So the problem that Excel put, you have to be careful here. Your B is minus 3. See this? Sorry, A is minus 3. So this is minus 3. Okay. B is 4, positive 4. And C is plus 1. So the first step is figure out what is A, B, and C. The discriminant formula is D is B square minus 4AC, right? All you do is plug in this. So the D is, the B goes right here, which is 4 square, then 4 times. The A is minus 3. This is the 3 will go right here, which is minus 3. And the C, I'll use a different color. C is this piece, orange color, which will go here, which will be plus 1. I'll just write 1. And then you end up getting 4 times 4 is 16. Two negatives makes it positive, and 4 times 3 is 12. And 16 plus 12 is 10, 28, see, which is positive. Again, you got positive, and this is two real solutions, and you're done. If you had to get negative, you would say two complex solutions. Okay? That's all it is. So I hope you guys got this. The whole uh, is there a 19.4 there? No, right? Is there 19.4? 19.3 is the end.